Okay guys, hi, it's Miss Rodriguez this time. I figured I would help out a little with Miss Weber doing all the videos. I thought I'd do one for you. So today we're going to talk about, this is now example 7 on the note section for infinite limits. And as you just heard, we showed you, reminded you actually, how to find the algebraic horizontal asymptote. Right, remembering that, and so therefore that gives us the infinite limit for each of these functions. And so we want you, whenever it says, and you have to be very clear about this, to use that algebraic method, you have to use the long way of finding that horizontal asymptote. So all of us could easily just look at this look at this function right here. We would compare degree of numerator, degree of denominator, notice that it's the same. So we would use our shortcut, divide lead coefficients, and we would know that our horizontal asymptote should be at 2/3. And you'll be like, well, why do I have to do it the long way? Well, because in this case, we are really trying to find the limit, so we want to see what happens as the limit approaches infinity. And with the function in this format, we can't actually see that. So we have to simplify it. Again, the technique is looking at the denominator, finding the largest exponent of the denominator, in this case x squared, and then dividing every single term by x squared. And so you just take the first one, 2x squared divided by x squared, the second one divided by x squared, same thing on the bottom. Every single term gets divided by x squared. And so now we go ahead and simplify all of that, and we see, right, that x squareds here cancel, x squareds here cancel, one of my x's here cancels, and then what am I left with, right? Well, I'm left in this case with 2 minus. Now this 5 over x squared, we're going to leave it like that for now. At the bottom I have 3 plus 1 over x plus 2 over x squared. And so what happens when we have a denominator that's very large, infinity, squared on the bottom? 5, a very small number, over a very large number becomes 0. Same thing here, same thing here. And so what I end up having is 2 minus 0, which is 2, 3 plus 0 plus 0, which is 3. And as we knew all along, we would get a horizontal asymptote, or the limit as x approaches infinity, of 2/3. Okay? Now again, for all these examples, you would just do the exact same process. Look at that denominator, divide by the largest coefficient, or the largest exponent. And so this next one right here is very similar. I'll let you guys do that one on your own. I'm going to jump down to example C. The largest one on the denominator in this case is x to the 4th. And so I'm going to divide every term by x to the 4th. Okay. And then let's see what happens, right? So x squared, this leaves me with an x squared on the bottom. This next one just gives me 5 over x to the 4th. Down here, they're gone. I have 3 plus x to the 1 over x to the 3rd. And then here, 2 over x to the 4th. And again, anything with a small numerator and a very large denominator will approach 0. And down here, similarly, so I'll have 0 over 3, which is just 0. If we go back to our method of using the shortcut, right, what did the shortcut say? Compare numerator and denominator degrees. Degree of numerator is 2, degree of denominator was 4. So since the numerator is smaller, that's when we always have a horizontal asymptote of y equals 0. And so as I'm approaching infinity, I will be approaching 0. Okay? Similar method for letter D. Again, since your denominator is bigger than the numerator, degree-wise, you are going to, again, approach 0, but I would like you to do this on your own to show the exact same method, using all these steps, showing every single little step of how, when we approach infinity or negative infinity, we indeed get to 0. Okay, down here, let's look at E and F now. These are a little different. Okay, so similar method, though, we're going to do the exact same thing. We're going to look at the denominator. What's the largest exponent? X squared. And I'm going to divide everything by x squared. And down here. Okay, and we simplify. So x cubed just becomes 2x minus 5 over x squared. Down here, I get a 3, 1 over x, 2 over x squared. Okay, so now I think as x approaches infinity, what's happening with all of these? Well, let's just do it one thing at a time here. The 5 over x squared we know is going to go to 0. The 1 over x is going to go to 0. The 2 over x squared is going to go to 0. So what do I really have? I have 2x minus 0, so that's just 2x. And in the denominator I have 3, right? So now I really think about, okay, let's kind of imagine what happens when x goes toward infinity. So a really, 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 really big number of x. You can kind of almost substitute, sort of a direct substitution of infinity into here. Okay, now we're really not substituting infinity because it's not a number, right? But you can kind of imagine a huge number being subbed in there. So it's like 2 times infinity, kind of a weird concept, over 3. Well, what's that going to be? It's going to be infinity. It's going to be a huge number. And so in this case, our limit as x approaches infinity of this function will be infinity. Okay, think about why that happens. What kind of asymptote do we have in this situation? Degree of numerator is 3. Degree of denominator is 2. When the degree on the top is bigger than the degree of the bottom, what do we usually have, or what do we always have? We always have an oblique asymptote, right? We have some sort of an oblique asymptote, and we would do long division in this case to find the equation of our oblique asymptote. But when we have that oblique asymptote, if you imagine, right, usually in this case, since the difference is just 1 between those exponents, it would be a linear asymptote. Right? So you've got some sort of a linear equation. And so as I'm approaching infinity, my graph is also approaching infinity. And now it could be either direction, I'm not sure which one. But just to give you a visual idea here, right, that as I'm going toward infinity, my y values are also going toward infinity. Okay, and so therefore, as x approaches infinity, my limit, or my y values, are also approaching infinity. Okay, I'm going to go through example F with you just because it's similar to this one, but again, it's a little different because it's the first one where we're looking at a negative. Okay, and we're going toward negative infinity. So let's do the same steps here. Divide everything by x squared. So 2x to the 4th over x squared. Okay, you can do this. Again, on your test, we need to see all of these steps to give you full credit. This simplifies 2x squared plus 1 over x minus 2 over x squared. On the bottom, I get 1 minus 5 over x squared. All of the ones with those x's on the bottom, as we've seen, are going toward infinity. So what am I left with here? I'm left with 2x squared over 1, right? Which is just 2x squared. Okay, but again, now let's think about, I'm approaching negative infinity. Okay, so again, you're literally plugging in negative infinity, if you will, right? So as I'm approaching a really, really, really small number, but look at what happens, it's x squared. So really I'm taking that negative infinity, and if you will, I'm taking a negative infinity and squaring it. Well, what happens when we square a negative? We get a positive, right? So this would be just like 2 times infinity squared. I know this is weird to think of infinity being squared. But the idea is what's happening here, since we square it being negative, it does become positive, and we get an overall positive infinity. Now your answers for these ones, again, this would be an example of an oblique asymptote. Degree of numerator bigger than degree of denominator, we would do long division, get our oblique asymptote. Your answers could either be positive or negative infinity. So you really do have to substitute it in and see what happens. In example E, if we were approaching negative infinity, we would have 2 times negative infinity, and my answer would end up being negative infinity. Okay, so be careful because it could be positive infinity, it could be negative infinity. So you do want to make sure that does make a difference in terms of when you're plugging stuff in. Okay, when we're plugging it into these ones up here with the negative infinity, it shouldn't matter as much because it's just still, in those denominators, it's still going to approach 0. There's not a positive or negative 0 with those examples, but with the oblique asymptote, again, it could either be going toward positive infinity, or in some cases, right, depending where I'm going, it could be going toward negative infinity in some sort of a graph. So you just have to be able to make sure you see that. Now this is not the real graphical representation of this one, but in a certain case it could have that example. Okay, good luck on your homework.